All right, calculus, this is 1.4. I'm going to use formula 1 to do this one. So this one says, find the slope of the tangent to the parabola y equals 3x squared plus 2x at the point whose x-coordinate is a. Now, when they don't give you an actual number value, that means they're looking for an expression where there's an expression with a in it, so you can plug any a value in and quickly get the slope of the tangent. Okay, so it's like a formula. So there's no actual value for a, you have to leave a in there. So formula 1 says this: the limit as x approaches a of f of x minus f of a all over x minus a. Now, because we have no numbers, we're not going to be able to simplify expressions or evaluate into numbers. So this might get a little bit longer. I'm not really sure, but let's see what we can do here. So let's start to fill things in. F of x is 3x squared plus 2x. That's going to be our f of x. Minus f of a is simply the function with a in for the variable. So that's 3a squared plus 2a. On the bottom, well, we leave x as x and we leave a as a. Next step of simplification. So do we have any like terms to gather here? Eesh, not really. We don't have any like terms to gather. So we're going to have to try and factor an x minus a out of here somehow. So is there any way that I can factor by grouping, or should I rearrange these somehow that we can factor something out? What do you think? Yes?
You can do 3x squared minus 3a squared.
Okay.
Create a difference of squares.
Yeah, so if I factor by grouping, so put some of the terms together that have a common factor. Now, x's have a common factor. Okay. If I pull an x out of here, I still have 3x plus 2, which doesn't help me with down here, right? So I think I like that. If you put the 3x squared and the minus 3a squared, yeah, you could pull a 3 out, and then you have x squared minus a squared. Wow. A few steps down the road, factoring x squared minus a squared will give you an x minus a. So that's exciting as a factor. But let's not go too far. So let's put 3x squared minus 3a squared together, and then we'll put 2x minus 2a together. So I'm expanding that negative in there and rearranging the terms a bit. Okay? All right, well, let's see. Where can we go from there? Yes, I can factor by grouping. I get a 3 and then a bracket, x squared minus a squared. And, oh, what happened here? Minus, did it disappear? That's a plus. So then I go plus, and now I can take a 2 out of here, and I get an x minus a. Ooh. Okay, well, this is factoring by grouping, and I do not have a greatest common factor between in my numerator here yet, right? But I can go further and factor, like you said about the difference of squares there. It's a great idea. Let's do x minus a. And again, you can factor parts of expressions. That's okay. You might get into, it's tricky because if you factor like this, if I'm factoring x squared minus a squared, you can totally do that. This is great. X minus a, x plus a, right? But when you just focus on part of an expression, you have to remember that these themselves are not factors of the numerator because you've got this plus in there. So that's what makes it tricky. You can't just go, hey, x minus x, you can't just pull one of these and scratch it off with the bottom and be done, because there's this plus in here. That's not a true factor of the entire numerator. So you have to be patient here. And in this case, we'll do one more step, because I like all these x minus a's. That's really, really good. Do you know why I like that? Is because I'm going to be able to now identify x minus a as a common factor in this term and this term. You see? So this might look a little funny, but I'm going to pull or factor out an x minus a. What's going to be left for me is 3 times x plus a plus 2. Now I've used the square brackets to differentiate, but you might just take a moment and just let that sink in there, okay? And it looks a little funny because I'm kind of crowding the previous line of work. Okay, so just take a moment, look at that, look at those two steps, and see if you can identify that I pulled out this x minus a from technically these two terms. There's one big massive term that's factored, and here's another term that's factored. So between those two terms, I have a common factor of x minus a, which I drew out. And what I'm left with, if this is gone, I'm left with 3 times x minus plus a. I'm left with 2 here. Any questions?
Why did you do the square bracket?
Okay, I did the square brackets just because I have round parentheses brackets here inside. So you don't have to do square brackets, but just too many round brackets, well, if they're all the same color, they might look a little confusing. So that's why I just did square. You don't have to. It's no big deal. Okay? All right, so finally, you can probably see where we go from here, right? We're going to go, because x minus a now is a factor up top, because it's this times all of this. So I can take this as a factor and divide it out from the one underneath. And so I have limit as x approaches a. This now simplifies to 3x plus a plus 2. And you don't have to, you can multiply that through, I don't care, it doesn't matter. But the cool thing is now, x is approaching a, so all the x's are a's now. You just substitute x for a. 3 times a plus a plus 2. That's 3 times 2a plus 2 is 6a plus 2. So let me just double check. Sorry, let me just double check here. Yep. Yep. Now I'm going to show you shortcuts. You're going to love it. To go right from here, right to there, like as easy as adding single digit numbers. I'm going to show you what the shortcuts are. It's going to be beautiful. You're going to love me. But you're not going to love me until chapter 2. Then I'll explain that to you. After, we got to get through this one, chapter 1. You got to do everything the full long way here. No, chapter 2 is good.
So it's not beautiful right now?
Well, I'm just going to teach you shortcuts coming later.
Oh, we like shortcuts.
We like shortcuts, but we got to know the long cuts first. You got to know those real well.
No, this
Is this your way of tough love?
Okay.
Tough love, exactly. Yes, tough love.
Should we bring brisket?
You should bring brisket. Did you say brisket? Wow, squirrel. I'm now distracted. Like the beef? Yeah, you should bring that. Why would you even say that? Why bring brisket?
There you
You're
go.
going to bring brisket to calculus class? We will stop what we're doing and eat brisket if you bring it. As long as it's not like
We should have a cook-off.
cold. Cook off.
But only with briskets.
I-
Everyone brings their own
I don't really like
briskets.
cooking. I like eating, not cooking.
You can be the judge.
Okay, anybody have any questions about this? Or dislike my use of red, blue, and yellow?
Yeah, I have a question.
Question.
So for the step where you have it expanded in the numerator, like 3x minus a, x plus a plus.
Like up here? Yeah, that way. Yeah, right here.
One with lots of color.
Yep.
Couldn't you already just factor out the x minus a because you can divide it out of both parts of the numerator? Like,
Well, that's what we did. I factored x minus a
yeah,
out.
But you like rearranged it in the line below. Do we have to do that in order to?
Well, this right here is factoring out. No, do you have to show this particular step? No.
Oh.
You probably don't. If you show this step, you can go right to this one
Okay.
probably. Yeah, you can just.
You could just.
So yes, what you're saying is that I know that if I have it here and then there's a plus sign, I have it here and I have it here.
Yeah.
These 3 are gone. Yes, totally. You can do that. As far as teaching purposes, I want to show you why this is gone. But yeah, for you, that's a step you could probably skip. You bet. Yeah. Any other questions? Awesome.